Just before starting this video, I purposely tightened all the screws and compressed all the springs. By doing this, it actually lowers the table far enough below the nozzle so that when I auto home, it doesn't hit. As you can see, when I compress the table against the rail, the part that moves, you can see it's a hole, it's a pass-through. Okay, there's no threads in this part at all. So basically the springs hold the table up and the screw holds the table and the spring down. So by adjusting the 4 screws with the adjustment knobs and turning it outward, it actually will raise the table up closer to the nozzle. So I'm going to go ahead and check the flatness of the aluminum using a straight edge on its side, corner to corner, side to side, top and bottom. Okay, so if you notice, if I move the light to this side and put the straight edge, you see that there's very minimal light showing through under the straight edge. So that would mean that it's fairly flat from this side to the other side across the plate. As I move it back further, you can see the same thing. It's fairly flat. No light shines through. If I turn it this way, again, no light shines through, as well as this way. So I'm pretty sure my aluminum table is fairly flat. You can check this, however, using a piece of paper, and you can actually slide it under the ruler. If it indeed has much of a gap, you will know when you slide the paper under the straight edge. With the aluminum table lowered all the way as it can go with the springs compressed, I'm going to go ahead and turn on the controller and auto home all the steppers. That would be the X, Y, and Z steppers. The X is first, the Y is second, and the Z is third. During auto home, it will hit the little micro switches. These micro switches do not move, and they are permanent. So whenever they are set and then reset, you are guaranteed to be set to 0. So the X, Y, and Z are now at 0. And you can see there's quite a bit of gap between my nozzle and the bed. As soon as it's been auto homed, you'll notice that all the steppers are still active. So I tend to actually go to disable steppers, disable the steppers so that I'm able to move the table and the print head back and forth. Be cautious, however, not to move the Z-axis worm gears, because if you disrupt those in any way, you'll have to go back and re-zero or re-auto home again. So knowing that this switch and the switch to the back are the 0 set switches, and they are not movable, non-movable switches. They will always be your 0 home setting, as well as the Z right here. I'm now going to go ahead and raise the gantry. This is the printhead gantry using the Z-axis stepper. So I'm going to go here to move axis. I'm going to go to 1 millimeter and down to move Z. And as you can see, the number is at 0 at this time. So when I move it up, the Z gantry goes up to the 38.0 mark and it stops. Now I can keep going up. And now I'm at 60. Now as I come down, I'll turn the knob all the way to 0 and automatically it will return to where it left off, where it started. As long as I don't make any moves or any changes, mechanically, it will always return back to its original position. I'm going to go ahead and raise it up to about 60. Okay, right now it's almost there. Okay, once it stops, I'm going to go ahead and place a flat mirror on the surface. And I tend to use the mirror for many reasons other than the fact that a print sticks well to glass. But I use the mirror not only for the glass being flat, but I use it for the reflection as well. The one thing about using a mirror is that in this particular case it's only 1/8 of an inch thick, so it's much lighter weight than the original glass. It's also due to the reflective properties of the mirror. You can actually see the image distort whenever the mirror is moved in one way or another. So I'm currently moving the table up and down, the whole thing, and I can see the reflection distort. Now one thing you can do to check that it is indeed flat against the aluminum plate is that you squeeze it from top to bottom so that you can actually see if the image distorts. And as you can see, it does not. The one important thing about using a mirror is that if you go ahead to your hardware store and purchase the 12-inch by 1/8 mirror, to be sure and sand all the edges with some light grit sandpaper, because they are not beveled and they are very sharp along the edge and the corners. I went ahead and added the clips, the 4 clips. There's one located near each corner, and this holds the mirror right up against the aluminum plate. As you can see, I'm squeezing it together and you don't see any deformity or distortion in the image. Okay, you can also check to see that it is flat against the aluminum plate by attempting to slide a piece of paper underneath, which as you can see I cannot. So that gives me a good indication that the edge of the glass and the mirror and the aluminum plate are indeed touching. And by squeezing it, you don't see any distortion in the reflection. And the same goes for the center. You can actually kind of squeeze toward the middle by maybe placing a hand underneath the plate and pressing down. You can also see if there's any distortion in the reflection by doing this as well. And in this particular case, I know the mirror is completely flat and totally up against the aluminum. If not, you can place aluminum foil in the gap, and that will help to alleviate any kind of distortion or any kind of gap within the aluminum plate and the mirror. Alright, now that I'm fairly confident that my mirror is resting firmly on the aluminum plate and any kind of shims if needed, are already in place. The reflection no longer distorts when I press the two aluminum plate and the mirror, the glass together. So now I'm going to go ahead and auto home again. And this time I'm going to check the distance between this side of the gantry and the frame by measuring with a scale, as well as this side of the gantry to the same place on the frame there. So I'm going to go ahead and auto home and go ahead and do that procedure. Now with the mirror in place, the gap isn't nearly as wide as it was, but I'm still going to need to go ahead and dial in the distance, and I'll do that with a piece of paper. Okay, so right now we're on the switch right here. And another thing, when you go to dial it in and use the paper for calibration, be absolutely sure there's no remnants of filament on the end of the nozzle there, dried filament on the end of the nozzle, because that will throw off the calibration between the tip and the glass. So be sure that that is completely free of any dried filament on the end of the tip of the nozzle there.